Okay, make sure you're taking notes and paying attention. It's hard for me when I'm not in the room with you taking notes to kind of see how fast I'm going. So if I'm going too fast, please feel free to ask Mrs. Sparks to pause and ask questions. We'll try our best here, but let me know. Okay, so today we're doing 4.2, which I can differentiate implicitly. Okay, differentiate once again means find a derivative. Implicit is our new method. So we've got the chain rule to find derivatives. Now we're going to use implicit differentiation. Okay. So let's first explore. We're going to find y prime here explicitly. Explicitly means we're going to get y by itself and do our normal derivatives. So let's do that. Let's get y by itself. Subtract 10. Divide by 2. Now that I've got y by itself explicitly, find the derivative is 3. That is explicit differentiation. However, let's look at this next one. If I wanted to find y prime here, I need to get y by itself. And I want you to think about that for a second. Some of you might try factoring out a y, but that doesn't work because it still leaves me with 2 y's. It's very difficult to get y by itself. Now it can be done. In this case, we could complete the square. And that may be brushing off a few cobwebs for some of us. So it can be done, but not always. You can't always get y by itself depending on what's going on. Especially if I throw in some trig in there too. So if I put plus cosine y, you're not going to get y by itself. So we need another method to find this derivative. So we'll come back to that. What implicit differentiation is we take the derivative of everything. Okay? But y, it's not a variable. It's a function of x. I should say it's not our independent variable. It's a function that depends on x. So whenever we take the derivative of a y, we're automatically going to multiply by y prime. And that is a form of the chain rule. Okay. So I'm going to take the derivative of the outside, which is the y, but I have to multiply by the derivative of the inside. Now we don't know what the inside is, because we're not told what y is, but we know we have to multiply by that y prime. Okay, so here's our process. Step 1. We differentiate both sides of an equation with respect to x. Okay, with respect to x. Then we get all of our y primes on one side. Then we're going to factor out your y prime to get it by itself. Solve for it, so that may include some division there. And then we should be good to go. So let's start with an itty-bitty dinky one. Eventually we're going to go back to the one we started with. Find dy dx if y squared equals x. Now, we know what this looks like. We could solve for y explicitly, but be careful if you do that, you actually have plus or minus square root. So we're talking positive square root, negative square root. This is not a function. So we're actually taking the derivative of something that is not a function. And that's okay now. That's what implicit differentiation is mainly used for, is things that are not functions. So we're not going to do that. We're going to practice implicit differentiation. So I take the derivative of this. That is 2y. Remember, y is not your independent variable. Okay? That is a function. So what I just did here is I did the derivative of the outside. I have to multiply by the derivative of the inside, y prime. Now, I don't know what y prime is. That's why I'm using a generic y prime. So every single time you take the derivative of a y term, you have to multiply by y prime. That's the derivative of the inside. It's a form of the chain rule. Okay. Now, some people might write dy dx instead of y prime. Perfectly okay, whatever you feel comfortable with. Now take the derivative of that. That's just 1. And x is a variable. We do not multiply by x prime or anything. That is a variable, not a function. It's only when we take the derivative of y. Last but not least, let's get y prime by itself. So y prime equals 1 over 2y. There's my derivative. And that's it. That is correct. However, this is where the AP test can get very, very tricky. They can give you a multiple choice and say which one is equivalent to the derivative. They have part 1, part 2, part 3. They say the answers could be parts 1 and 2, parts 2 and 3, parts 1, 2, and 3. Because this could be my answer, or this could be my answer, excuse me, wait. Or even this could be my answer. I want you to take a second to try to figure out where the heck I got that. If you can solve for y, remember this was plus or minus square root of x? Sometimes the AP test or even your book might do this occasionally being tricky, so when you're checking answers, be careful. They might plug in y is square root of x. Boom. Y is negative square root of x. Boom. These are the exact same thing. They are saying the same thing. They are all derivatives depending upon your domain. Okay? So we have to be very careful when we're doing multiple choice and implicit differentiation. But there can be more than one answer. But that is, once again, only if you could have gotten y by itself. Many problems we cannot, so you can't have multiple answers if you can't get it by itself. This is the easiest one. This is the one we're going to go with. Now we're going to find the slope of a circle. X squared plus y squared equals 25. The slope of a circle. I just want to refresh your memories in case it's been a while. Circle equations. That is the equation of a circle. So compare it to what we have. You do not have a minus, we actually have minus 0, minus 0. So my center is 0, 0. And my radius, this is r squared. My radius would be 5. So just to get a picture of this, it's a radius of 5. Just to bring back a few memories of circles here. We don't need that for this problem, but it gives us a little bit of a reference. Especially when we go to evaluate my point. Let's go ahead and do our derivative. Is it possible to get y by itself? The answer is yes, but it's a little more complicated because we will have that plus or minus square root in there, and we don't want to take two different derivatives. So let's go ahead, differentiate implicitly. So it's 2x. Now the derivative here is 2y, but you took the derivative of a y term, so you have to multiply by y prime. This is where a lot of people mess up. The derivative of 25 is 0. Don't forget those constants. Now I need to work on getting y prime by itself. So subtract 2x, divide by 2y, and please reduce. There's my answer. Well, part of it, I have to evaluate. Sorry, I haven't finished. Okay, so that's my derivative, but it wants me to evaluate at the point 3, negative 4. So let's plug in y prime negative 3, this is negative x, over negative 4, which is 3/4. That should sound reasonable. Here's the point 3, negative 4. Positive slope of 3/4 should sound reasonable if we get a kind of a picture in our heads. If it was over here, we know we should have a negative slope. Likewise here. Let's try another one. Okay, so let's find the derivative of dy dx. Once again, it's another way of saying y prime. So take the derivative, that is just 2, but you took the derivative of y, multiplied by y prime. Here is 2x. Derivative of this is cosine y, but you took the derivative of a y term, multiplied by y prime. Now we need to get all of our y primes on one side. So I'm going to subtract this term to get it over here. So I have 2y prime minus cosine y times y prime equals 2x. So you want everything on one side, everything else on the other. That should sound familiar. Chapter 1 We did some logarithms like that. We solved logarithms, and we did some inverses like that. Now let's factor out y prime. 2 minus cosine y, 2x. Finally, divide by all that junk. There we go. Once you have y prime by itself, you're good. Don't you dare kill a kitten. Don't you try to cross those 2's off. That's subtraction. That's all we can do there. Now in this one, you get a y and a y here. There was not a possible way to get y by itself. You could not differentiate explicitly. We had to use implicit differentiation. It's easier anyway, but it's our only option on this one. Okay, this one people mess up on a lot, but it's a pretty standard one. Find the tangent normal line, that at the point -1, 2. And here's why people mess up. Right here. Variable times variable. We have to use the product rule. Now, when you do that, do the product rule and then distribute your negative. That's where a lot of people mess up too. They don't distribute that negative. So here we go. I'll have 2x minus, let's do the product rule between these two, which is the first, the derivative of the second is 1 y prime. We took the derivative of y. Plus, derivative of the first is 1 times the second. Okay, so that's my product rule. So once again, it was the first, derivative of the second was 1 y prime, and then the derivative of the first is 1 times y. Over here, 2y, y prime equals 0. Distribute your negative. Now we need to get all of our y primes on one side, everything else on the other. It doesn't really matter. I'm going to keep the y primes on this side and take everything else over. I'm going to try to keep things as positive as possible, though. I'll take that positive y minus 2x. So I took this over and this over. I also switched the order here because I just like that leading coefficient to be positive. It doesn't really matter, though. Factor out a y prime. Divide by that junk. And last, make sure you can't reduce. There's nothing they have in common. Don't you dare try to reduce any of those x's or y's or the 2's. There's subtraction going on there. Oh, did we have to evaluate? Oh, we did tangent normal line. I'm nowhere near done, am I? At the point -1, 2. It's nice to give us both x and y. So let's find our slope. Let's see, it was -1, 2. So my slope, y is 2 minus 2 times -1. 2 times 2 minus -1. Give me 2 plus 2. 4 plus 1, 4/5. So that's my slope. Now let's do a tangent line. So y minus 2 equals 4/5 x minus -1. Distribute. And add up. If you need to go off to the side, do a little work. 4/5, we're adding 2, common denominator. So we're getting 4/5 x, 10 plus 4, so plus 14/5. There's no need for a calculator on any of this. Now let's do our normal line. So the same thing, y minus 2, except my slope is opposite reciprocal, which is -5/4. X plus 1. Distribute. Okay, so I'm doing -5/4 plus 2/1, common denominator. So I give me 8 minus 5, so 3/4. Circle my answer. So the only thing new here is how we did the derivative. Nothing new in the tangent normal line. That's the same old, same old. It's just how we did the derivative is what's new. Once again, if I'm going too fast or you have questions, make sure you ask Mrs. Sparks to pause. before we do the u try, let's go back at our beginning one. This is the one where we could not get y by itself. So let's go ahead and use implicit differentiation. So the derivative of 2y is y squared is 2y, y prime, minus 1 y prime equals 7. Let's factor out a y prime and divide. I don't know about you, but I would prefer implicit differentiation any day to having to complete the square and then do a derivative with the chain rule. Blech. So implicit differentiation is another shortcut. It is a shortcut for more complex, not necessarily functions, but expressions. Okay. So now we're going to do the u try. Obviously we're not going to click in today, but I want you to kind of work this on your own. So in a minute you're going to pause this, and then when everyone appears to be done, Mrs. Squires will hit play again and we'll go over it. Okay, let's do our derivative here. We're going to have 2y, y prime, minus 2 minus 4y prime, 0, 0. So get your y primes together. Oops. Everything else on the other side. Factor out a y prime. Now this I can reduce a bit. Everything can be divisible by 2. Didn't have to because we're plugging in. But if we were going to go do a second derivative, which we're going to in a minute, I would definitely reduce by 2. So there's my slope. Let's evaluate at the point 2, negative 1, or negative 2, 1. So I have 1 over 1 minus 2, which is negative 1. There's my slope. So let's do a tangent line. So I have y minus 1 equals negative 1, x minus negative 2. Add off, negative x, add 1, minus 1. Okay, let's do a normal line. Y minus 1, opposite reciprocal would just be 1, x minus negative 2. Y equals x plus 3. There we go. Okay, now that we have that down, we're going to go on to second derivatives. Okay, to find second derivatives, you first find y prime using implicit differentiation. Duh. Find the second derivative, you obviously have to find the first derivative. Then find the second derivative using implicit differentiation. We're just going to do another one. But the last thing that's kind of weird is you have to plug y prime into y double prime, because your answer should only be in terms of x and y. No y prime should be in there. Let's try one. These are pretty lengthy, okay? So write small. These can get pretty in depth, those second derivatives. You have 2 on homework, okay? They can get pretty in depth. So let's go ahead. Once again, this means second derivative. So I will get 6x squared minus 6y, y prime, equals 0. Make sure you take the derivative of that constant as well. Okay, let's take some stuff over. So 6x squared. Try to keep it positive. That will just make your life a whole lot easier. And please reduce. I get x squared over y. So there's my first derivative. Now let's work on taking my second derivative. Now, in order to take the derivative of this, I could use the product rule, the chain rule. I would definitely go with the quotient rule here. Quotient rule is way easier than doing the product rule in this case. So the quotient rule says the bottom, the derivative of the top is 2x, minus the top, the derivative of the bottom is 1 y prime. All over the bottom square. Now let's clean this up a tad. 2xy minus x squared y prime. Now this is what I'm talking about here. I do have my second derivative, but it has to be in terms of only x and y. No y prime. So what I'm going to do is I'm going to substitute in This whole thing equals y prime, so plug it in. So y prime equal x squared over y. Clean that up just a tad. Like I said, I need to get messy. This one actually is a pretty clean one, believe it or not. It's a square. Okay. Now, two options here. I can't leave that fraction in there, so I can either do a common denominator then KFC. That's more work. The easiest way is just multiply by that denominator. See that y? I'm going to multiply the top by y and the bottom by y. But when I do that, you have to distribute y to both terms. So when I do that, this one will be 2xy prime. Here, they'll reduce. I'm left with x to the fourth. Voila, no more fraction. On the bottom, I end with y cubed, y squared times y. There we go. What do I have here? That's a y squared. Sorry. Let me just do it fit. So 2xy squared minus x to the fourth over y cubed. So now I have my second derivative in terms of x and y only. These can get very messy. Reduce as much as you can as you go. Let's try one more, and I think we're done. Okay, so once again, be very careful. Variable, variable. Split this up and do the product rule of this and that. So the first, the derivative of the second is 1y prime plus derivative of the first times the second. That's 0 and 0. I'm actually going to move some of this over and give myself a little more space. Okay, solve for y prime, so I have negative 5x y prime equals 5y. Y prime equals 5y over negative 5x. So y prime is negative y over x. When I put my negative up top. Okay, so I have my first derivative. Let's do my second by doing the quotient rule. So I have the bottom. The derivative at the top is negative 1 y prime. Minus the top times the derivative of the bottom, which is 1. All over the bottom squared. So let's clean this up. I have negative xy prime plus y over x squared. Okay, got my second derivative, but I have to get rid of that y prime, so plug in your y prime here. So I have negative x, negative y over x, plus y. Ooh, this one's nice. This is nice because these x's reduce. There's no need for multiplying by something weird. So I just get a positive y plus y